My name is Sean Patrick MacDonald. I am the co-founder and chief technology officer at SimCraft.
Today we're going to talk about what makes SimCraft different. Full body feel, or motion simulation. Motion simulation has been around since the early 1950s. The Stewart platform, the hexapod, was invented back then for aviation. And there's a whole lot of other approaches out there on the market, some of which just move the seat around, leaving the steering wheel and pedals and the cockpit ultimately stationary. But there's really only one way physics work, and realistic motion simulation must take the lead from how vehicles behave in the real world, how they rotate, how they translate. Simulation, after all, is a recreation of a process or a system over time. The recreation of the environment is the key here. So it's based on a real-world application of racing a car, and the physics is our guide for how to move the cockpit. So there are 6 degrees of freedom in physics that intersect at the center of mass of a vehicle. There's 3 rotations and 3 translations, and those degrees of freedom are governed by the center of mass. All vehicles are governed by this. The cockpit in a SimCraft motion simulator becomes the virtual vehicle, and the rotations and translations of the simulation occur at the center of mass of the cockpit. So ultimately the cockpit becomes the vehicle, the virtual vehicle, and the relationship of the driver to the controls and the graphics, which show the perspective out the windshield, doesn't change during the simulation. They all move together as one. And we do it this way because this is how it works in the real world. The structures that are built around our cockpit are designed to support a mass. They're designed to create a degree of freedom, an axis of rotation, one frame and a series of rotational bearings that support the load. Supporting the load is important because the actuators, the devices that are providing the motion cue, can operate at a high efficiency and can deliver motion cues without perceivable delay. So this methodology allows for independent degrees of freedom, or degrees of freedom that are completely separate, both mechanically and logically, from the other degrees of freedom. This is important because that's how it works in real physics. The approach also allows us to package various units with different degrees of freedom. Many combinations, small footprint units up to 3 degrees of freedom, and our large footprint unit, which goes all the way up to full motion, 6 DOF. And every unit we build maintains the same approach to motion, translating and rotating at the center of mass of the cockpit, independent degrees of freedom. And the structures around the cockpit are designed to support it, so the actuators can work efficiently. The entire system is modular, which allows our clients to build up an upgrade from any point in our product line all the way up to 6 degrees of freedom. And every degree of freedom is also individually tunable in real time. So ultimately, when the sim is dialed in for the driver, they can feel 100% connected to the sim environment. And the combination of the supported load and the independent degrees of freedom that rotate at the center of mass, it's how physics works. So I feel it's the most scientifically accurate method of simulating vehicle motion. And this is why it feels so real and translates into real racing driver development.